Okay, so here, let's use the sum and difference identities to find exact answers for the following. Okay, so here, our goal is not to use calculator and utilize the special angles. Okay, for the special angles for us to identify the answer. Okay, without using the calculator. Okay, so let's start first with this example. We have your sine 105 degrees. Okay, so sine 105 degrees, we can express that using some identity for the sine. Sine A cosine B plus cosine A sine B. So splitting that 105 degrees to 60 degrees and 45 degrees. Okay, so with that, we'll have sine 60 degrees cosine 45 degrees plus cosine 60 degrees sine 45 degrees. Okay, so as we all know, we have our technique in identifying this. Okay, we can use the hand technique or you just memorize those special angles. Okay, so sine 60 is the square root of 3 over 2. Cosine 45 degrees is a square root of 2 over 2. Cosine 60 is 1 half. And the sine 45 degrees is square root of 2 over 2. Okay, so we'll apply here the concept of the radical. So we'll have there uh, for sine 105 degrees as the square root of 6. Okay, so we have your square root of 3 times square root of 2, that is square root of 6. Over 4 plus 1 times the square root of 2, which is square root of 2, over 2 times 2, which is 4. So therefore, we'll have the result of square root of 6 plus square root of 2 all over 4. So as you can see here, we use the special angles for us to identify the answer without using the calculator. Let's have another one. Cosine 15 degrees. So in this case, let's try to use, again, the 60 and 45 degrees. Okay, but the difference, identity for the cosine. So we'll have here cos, sin, and we have the operation of plus. Okay, so as we substitute that 60 degrees and 45 degrees, so that's 15 degrees, obviously. So cosine 60 degrees is 1 half. Cosine 45 degrees is square root of 2 over 2. And the square root of 3 over 2 is the sine 60 degrees. And then sine 45 degrees is square root of 2 over 2. Then same procedure, multiplying this will obtain square root of 2 over 4 plus the square root of 6 over 4. Or simply the square root of 2 plus the square root of 6 all over 4. So therefore the sine 15 degrees, the cosine, it should be cosine, correction. Cosine 15 degrees is square root of 2 plus square root of 6 over 4. Okay, again, correction, it should be sine instead of cosine. Since we're after here with the cosine. It should be cosine. Okay, it should be cosine. Okay? Let's have another example. For number 3, cosine pi over 6 times cosine pi over 7 minus sine pi over 6 times sine pi over 7. So here in this case, we can have the reverse process of this. Okay, because as you can see, we have the cos cosine sin. Okay, cos cosine sin, which is the difference, the sum, rather, the sum of the cosine identity. Okay, so as you can see, as you remember, when it comes to cosine, we reverse the operation here. So we'll use that plus. Okay, so we'll have cosine A plus B is equal to cosine A cosine B minus sine A sine B. Okay, so let's say our A here is pi over 6 and our B is pi over 7. So as we substitute that, we'll have this. Okay, and cosine pi over 6 plus pi over 7. So finding the LCD, which is 42, simplifying this is 13, 7 pi plus 6 pi, which is 13 pi over 42. So therefore, this is just simply as cosine 13 pi over 42. So as you can see, It's just the reverse process. Okay, it's just the reverse process. And then for number 4, sine 23 pi over 12. Okay, so again, it's important for you to realize the special angles. Okay, for you to answer this. Because we should not use the calculator in this case. So here we can say, let's use the addition or the sum identity for the sine. Okay, and 23 pi over 12 is the same as 5 pi over 3 plus pi over 4. Okay, 5 pi over 3 and pi over 4. So if we add that, the result of that is 23 pi over 12. So as we substitute, we have here sine 5 pi over 3, cosine pi over 4, plus cosine 5 pi over 3, and sine pi over 4. Okay, as you can see here, this is 5 pi over 3 is the same as 300 degrees. Okay, you can use the reference angle for you to identify, okay, the uh, answer here. And just consider the sign. Since this is 300 degrees, this is in quadrant number 4. So the cosine is positive, but the sign is negative. Okay, so we have here sine 5 pi over 3, which is negative square root of 3 over 2. Okay, so that is a reference angle of 60 degrees. So that sine 60 is square root of 3 over 2. However, this is a in quadrant 4. 300 degrees is in quadrant 4. So therefore, this is negative. Okay, the sign is negative there. Okay, and then for cosine pi over 4, that is 45 degrees. So square root of 2 over 2. Plus cosine 5 pi over 3. So cosine 60 as our reference angle. So that is 1 half. And as we all know, cosine is positive in quadrant number 4. So the answer here is 1 half. Okay, the answer is 1 half. And then for sine pi over 4, sine 45 degrees is square root of 2 over 2. Okay, then simplifying this, square root of 3 times square root of 2 is just square root of 6 over 2 times 2, which is 4. So then we have here a negative. And then here, 1 times square root of 2 is square root of 2. Then 2 times 2 is 4. So simplifying that, we'll have negative square root of 6 plus square root of 2 all over 4. Okay, so again, reminder here, you can use this special angles, but you just need to recall, okay, the reference angle for you to answer this. Okay, you can use the strategy of the memorization of those special angles or just the fundamentals, the hand technique, and consider the sign depending on the quadrant of the given angle. Now, how about for the double angle identities? So in double angle identities, we'll use the concept of the SAM identity for the sine, cosine, and the tangent. Okay, so first off, let's have the sine. Okay, sine theta plus theta. So let's say we have 2 theta. So that is sine theta cosine theta plus cosine theta sine theta. Okay, so as you can see here, we have common, which is sine theta and cosine theta. So if we add this, it's just simply as 2 sine theta cosine theta. So double angle for the sine is 2 sine theta cosine theta. Okay, so remember this. Okay, additional identity for the double angle. Well, for the cosine theta plus theta or cosine 2 theta is equal to cosine theta minus the sine theta. And cosine theta times cosine theta is cosine squared theta. And then sine theta times sine theta is sine squared theta. So the double angle for cosine is cosine squared theta minus 1 minus sine squared theta rather. Okay, so you can manipulate this and use the Pythagorean identity and obtain different results. Okay, so for instance, we have here, if we substitute 1 minus cosine squared theta, the Pythagorean identity here, for the sine squared theta, we'll obtain cosine squared theta minus 1 plus cosine squared theta. Okay, or just simply 2 cosine squared theta minus 1. Okay, so as you can see, we use another identity. Okay, which is which is derived from the Pythagorean identity earlier. Okay, another one, instead of the sine squared theta, we can substitute also in cosine squared theta. So in that case, we'll have 1 minus sine squared theta minus sine squared theta. Okay, and then combining this, we'll obtain 1 minus 2 sine squared theta. Okay, so it's important for you to remember also those derived identities for you to obtain this identities. Okay, so just be familiar with this, then you'll obtain another identity. Okay, so another one will have in tangent. So tangent theta plus tangent theta is equal to tangent theta plus tangent theta all over 1 minus tangent theta tangent theta. Okay, so tangent theta is plus tangent theta is just simply 2 tangent theta. And then tangent theta times tangent theta is just simply tangent squared theta. So therefore, for the double angle of the tangent, that is 2 tangent theta over 1 minus tangent squared theta. Okay, so remember this 3 because it's very important whenever we are solving for the double angle. Okay, we will utilize this later on. Okay, so again, same procedure. Let's try to solve this. Sine 120 degrees. So in this case, we can manipulate if we will use the double angle identity here. So we'll have the sine 2 theta is equal to 2 sine theta cosine theta. Okay, and since this is 2 theta, okay, so 120 degrees can be expressed as 2 times 60 degrees. Okay, 2 times 60 degrees. So with that, let's substitute. Okay, so sine 2 times 60 degrees is equal to 2 times the sine 60 degrees cosine 60 degrees. So from this, let's try to substitute. Okay, so 2 sine 60 degrees cosine 60 degrees. So as you recall, sine 60 degrees is just simply square root of 3 over 2, and cosine 60 degrees is just simply 1 half. Then simplifying this, so this is cancel. So the result here is square root of 3 over 2. So sine 120 degrees is equal to square root of 3 over 2. Okay, so here, actually, sine 120 degrees, you can use the special angles, the reference angle, then you'll obtain the answer. But also, with the use of the double angle identity, we can solve this sine 120 degrees. Another example, sine 4x. So same procedure with the previous example, just use the sine double angle identity. And we can express that 4x as 2 times the quantity of 2x. Okay, so with that, again, all you need to do from this one, all you need to do is to substitute from the derived identity earlier. So sine 4x or sine 2 times the quantity of 2x is just simply 2 sine 2x cosine 2x. Okay, so here actually no need to simplify this, and this is the answer. Okay, but if you want to use again the other identities to simplify this, then you can proceed also. And then for number 3, sine x cosine x. Okay, so here you need to remember the 3 identities which includes the sine theta cosine theta. Okay, so in the first 2 examples, obviously we have here the sine theta cosine theta. Okay, so we can use that sine double angle identity, okay, to identify this one. So as we all know, the formula for this is 2 sine x cosine x. Okay, and if we divide it both sides by 2, then we'll obtain the double angle of sine over 2. So the equivalent of sine x cosine x is just equal to the double angle of the sine over 2. Okay, so sometimes we just need to manipulate, okay, our data to our uh, formula, okay, our identity to obtain our answer. Okay, and then for number 4, let's have an example. Cosine x is equal to 1/3, and the angle is between 0 degrees and 90 degrees. Okay, so let's try to solve for the sine 2x, okay, or double angle of the sine. So in this case, we have the formula for the sine, which is 2 sine x cosine x. And then here, provided that we have the cosine x, which is 1/3, so we can substitute that. And now, let's solve for the sine x. Okay, so here you can use uh, the Pythagorean theorem to identify the sine x in identifying the uh, other side. Okay, or you can just apply, okay, the formulas that we have earlier, okay, to obtain the sine x. So it depends on you on how you identify the value of x. So of the sine x rather. So in this case, sine x or the sine theta is equal to 2 square root of 2 over 3. Okay, again, you can use the Pythagorean theorem to solve for this. Okay, you can construct a right triangle, okay, to obtain this, to visualize this, or you can just use the formula that we have earlier. Okay, so with that, we can now substitute this cosine x and sine x. Okay, it should be x. Okay, which is this one. 2 times the quantity of 2 square root of 2 over 3 times the quantity of 1/3. Okay, now let's simplify. Okay, let's simplify. And the answer of this is 4 square root of 2 over 9. Okay, kasi we have here 2 times 2, which is 4, and then 3 times 3, that's 9. So sine 2x is equal to 4 square root of 2 over 9. So again, you can use our previous method in identifying the sine, and at the same time you can use also the different identities that is derived earlier, okay, to obtain the value of the sine x. Another example, we have here cotangent x is equal to 4/3, and we have here the angle between the pi and 3 pi over 2, okay, which is 180 degrees and 270 degrees. So let's identify the tangent 2x, okay, or the double angle for the tangent. So as we all know, we have the formula for the tangent as 2 tangent x over 1 minus tangent squared x. So in this case, we have the cotangent x. And if we will use the concept of the quotient, the reciprocal identity, uh, all we need to do is to reciprocate this 4/3 and obtain the tangent value. Okay, and the tangent x here is 3/4, just 3/4. Okay, now, and we can substitute it here in our formula. So tangent 2x is equal to 2 times the quantity of 3/4 all over 1 minus the quantity of 3/4 squared. And then with that, you can use your calculator or you can simplify this complex fraction. And you'll obtain the value, which is 24 over 7. So the tangent to x here is 24 over 7.